guys, once again welcome to DTech YouTube channel. So in this video we will talk about tree data structures. As I know, I think you guys have watched my previous videos and liked them. So today we will start on tree data structures. So what is a tree? A tree is a non-linear data structures that simulate a hierarchical tree structures with a set of nodes. So basically a tree looks like trees in a hierarchical manner. So basically the tree data structures used in various applications such as in file handling and database and compiling applications and some networking AI applications. Also this data structure will be used. So basically the data is stored on these nodes. So these are called as nodes. So in our next chapter we will learn more deeply about these nodes and more on these structures. So guys, in this chapter we will talk on basic tree terminologies. So this is a basic tree structure, and this is called a node. The nodes used to store data in a tree. So basically this is a node. Node used to store data in a tree structure. The topmost node of the tree, or the starting point of the tree, is called as the root node. And in this structure, the topmost one is the A, so it is the root node. This is the root node. The topmost node, or the initial point of a tree structure. And so we have learned the node and the root. Every point is a node used to store data. Specialty is this is the root node, or the starting point of the tree structures. The nodes with one or two child nodes. Nodes with one or two child nodes are called as the parent node. So in this structure, this B is a parent node because it has child nodes, and F is a parent node. It has child node C, E and G, and A is a parent node of B and F. So these are parent nodes with one or more child nodes. Child node are these. Child node has only a parent. Child node has a parent. So CD, parent is E, and EG, the parent is F. And V and F has parent A. So these are child nodes. So nodes that shares one or more child. Nodes that share the same parent. Node that shares the same parent. The C and D are nodes that share same parent B. And E and G nodes that share same parent F. D and F nodes that share same parent A. These nodes are called as sibling nodes. Sibling nodes. Sibling nodes are nodes that shares a same parent. Share same parent. So I think you have got a basic idea of the structure of the tree and the main parts of the tree. And in additionally, these are nodes with not child nodes. Nodes without child nodes are called as parent nodes. Not parent nodes, leaf nodes. Nodes without child nodes are called as leaf nodes. So these pair nodes without child nodes. So nodes without child called as leaf node. Nodes without child nodes are called as leaf nodes. So, and the connection between these two nodes, connection between nodes are called as, the connection between these nodes are called as the edge. This is the edge. Edge is the connection between two nodes. So, number of edges. The number of edges from root node to a root node to a sub node. Let's see, from here to here. The depth is the number of edges. We know that edges are the connection line between two nodes. So then the depth means the number of edges from root to specific point in the structure. So depth means depth. Depth means the depth of the tree means number of edges from root to specific point of the tree. Then the height, number of edges from root node to the final level of the tree structure. Number of edges from root node to final level of the structure is called the height, and it is the longest path. So from root to final level is this. So the height is 1, 2. So height of this tree is 2. So the 2 is the longest part in this tree structure. Height. And this each and every level, each and every part is named as levels, defined as levels. This is one level, this is another, and this is another. So each level is named from 0 to from 0 and continue. So this is the initial point or the starting point. So the level is 0. The next level is 1, and the final is the level 2. So this is the basic points, the basic things in a tree terminology. For a quick summary, nodes used to store data, and the starting or the most topmost node is the root node. Then edges are the connection between two nodes, and the parent node can be identified with, if a node connected with 2 or more child nodes, it is a parent. And sublime nodes, sibling nodes are if node shares the same parent, it is defined as a sibling nodes. And nodes with a parent is known as a child node. Nodes with a parent is known as child nodes. Then we learned about the depth. Depth means the number of edges from starting point to a specific point in the tree structure. And an important thing is a degree of the tree. Degree of a tree means number of child nodes that a nodes particularly have. If we pick a node B, he has 2 child nodes. So his degree is 2. Degree is 2. A, what is degree of A is B and F. Well, degree of A is 2, as it has 2 child nodes. So degree is the number of child nodes a particular node has. Degree is number of child nodes but a particular node has. So I think you have got an idea about basic tree terminologies in these tree structures. So in our next chapter we will learn some more important points about a tree and nodes. So So let's talk about important points of these trees, more specific important points. All nodes will have 0 or more child nodes. Okay, all nodes will have 0 or more child nodes. So for example, this is node, you can have more child nodes, or it can have 0 child nodes. All nodes will have a 0 or more child nodes. For all nodes other than root node, there is one parent node. For all nodes other than root node, there is a parent node. For all nodes other than root node have a parent node. For example, so starting point of this structure is a root node. So in this tree structure, for a root node there is no parent, but but nodes have parents, but root node doesn't have a parent. And so each node in a tree exists a unique path from root node to a specific node. For each node have a unique path from root node to that specific node. To specific node. The length of these paths is the depth of the node. The length of these paths is the depth of the node. For example, if we take the depth of this node, depth means that the length from root node to this specific node. Length or the edge from root node to this specific node is the depth of this node. So length from root to specific point, root to specific node is the depth. So if we select this as root and this as a node has a node has depth of 2, and the depth of the root node is 0. The root node R is 0 because root doesn't has a path. That's why its depth is 0. Height of a tree, so the height of the tree defined as the maximum depth of any node within the tree. So height of this structure is the maximum depth from any node within the tree. Maximum depth within the any node in the tree. So root node, but the root node has, so the root node has height minus 1. The height of the root node is minus 1 because it doesn't has a specific depth, because in we talk that the root node depth is 0. So height of the the height of the root node is 0, and the height of the empty node, empty tree, the height of an empty tree is minus 1. But empty tree is minus 1. Height of a root node is 0. Height of an empty tree is minus 1. So I think for a quick summary, we had talking that all the nodes can have 0 or more child nodes, but the root parent node has a root node doesn't have a parent node, and each node has a unique path from root node to a specific point, and the length of the length to a specific node from the root node is called as depth, and the maximum depth is called as the height. And two more important points: the height of the tree is 0, and height of an empty tree is minus 1. Height of the root node is 0, but the height of an empty tree is minus 1. So I think in this video you have got a basic idea of tree terminologies and about tree data structures. In our next video, we will continue the implementation of these tree data structures. So please subscribe my channel, like my videos, shares my videos, and thank you and goodbye. See you.